So Unit 6, Lesson 1, Introduction to Similar Triangles. So let's talk about some couple of words here. One is similarity. And so when you talk about similarity, similarity means that we have two objects. And when we talk about these two objects and we compare them, these two objects have the same shape. Okay. And not only do they have the same shape, but that shape could be an enlargement or a reduction in size. So imagine you have a triangle, you keep the same triangle shape, but it's just a reduction or an enlargement of its size. And it has to have corresponding pairs of sides that are proportional to each other, as well as corresponding angles that are the same, right? So if I looked at something like this triangle and this triangle, they both are triangles, but they're not similar because they have different proportions of corresponding sides and angles. So two objects have the same shape, and the corresponding pairs of sides are proportional and corresponding angles are the same. Okay, so that's similarity. Congruency, or what congruent means, is that you have two objects that are the same. So two objects are the same shape and size. So we talk about similar triangles. So this unit's all about studying triangles, not squares, rectangles, or other shapes, just triangles. And there are two things about triangles that we need to know to say that they are similar. So one is that, okay, corresponding pairs of sides have the same scale factor. In other words, this speaks to the proportional reasoning of the two pairs of sides. And the second thing is corresponding angles are the same. So we're going to use these two properties of similar triangles to help us understand what similar triangles are all about. So I'm going to take two triangles down here, and I'm going to label this one on the left A, B, C, and the one on the right D, E, F. Now when I make a similarity statement about my triangles, I'm going to say they are similar. So the way I write that is by saying triangle A, B, C is similar to, so this tilde sign means similar to, triangle D, E, F. Now notice the way I wrote them. Triangle A, B, C, D, E, F, the letters are written in the order which are corresponding to each other. So angle A corresponds with angle D, so those are the first letters in the triangle name. Angle B is a 90-degree angle, and so is angle E. So I put that corresponding to each other. So B matches with E, and here I'll write A matches with D, and also if I pick a different color here, let's try yellow, I can say C corresponds with F. So two angles, so let's say angle C and angle F correspond to each other. And the same idea can be done for corresponding lengths. So if you look at the order in which I write the letters, AB is the length AB over here, and the corresponding on the other side, in the triangle on the other side, on the right side, is DE, and that is these two letters right here. So the letters in the order that they appear, paired up beside each other, also represent corresponding lengths. Okay. All right. So if these two triangles here are similar, well, let's say they are related by a scale factor. So let's say this one is an enlargement of a scale factor of 2. So scale factor of 2. That can help me get some of the side lengths of the smaller triangle ABC. So if EF is 8 centimeters, then over here I could say BC is half of 8, which is 4 centimeters, because 4 times the scale factor of 2 gives me 8. Similarly, if 10 centimeters is the length of my hypotenuse here, then the length of the hypotenuse in the smaller triangles is 5. And so that's 5 centimeters, right? And then if I wanted to find AB, I could use the Pythagorean theorem and find out that AB is 3 centimeters, right? And the scale factor of 2 means that DE is 6 centimeters. Okay, now there's 3 ways you can prove 2 triangles are similar. 3 methods. The first one is by comparing corresponding angles. If you can find 2 angles, so AA, if you have 2 corresponding angles that are the same, then your triangles are similar. So 2 corresponding angles are the same. The second way to tell if 2 triangles are similar is by checking all 3 pairs of corresponding sides, so SSS. So if all 3 pairs of corresponding sides have the same scale factor. And I'll show you how that looks like in some later examples. And the third way to tell that they are similar is if you compare 2 sides and the angle between them. So SAS. So 2 sides, so 2 pairs of corresponding sides have the same scale factor, and the corresponding angle between, underlined between, is the same. Okay. Okay, so I'm going to go through some examples of 2 kinds of questions that you're going to see. So the first question, here let's create a triangle that's similar but not congruent. So I have triangle A, B, and C. If I want to create a triangle that's similar, well, I'll start by creating something of similar shape. Okay, and let's label this different letters. So let's label this GHI. Now for this triangle GHI to be similar, corresponding angles have to be the same. So angle I has to be 60 degrees. Now the lengths can't be 3.3, 3.7, and 2.4. Otherwise they'll make it congruent. I could multiply each number by a scale factor. So what if I multiplied it by a scale factor of 10? So then I can make this side 33 centimeters, H to I 37, and G to I 24. So I've just enlarged my triangle by a factor of 10. Now it may not look like it on paper because I can't draw that big of a triangle on paper. So use your imagination. You can multiply all 3 sides by a number to get another number, as long as they're all multiplied by the same scale factor. And that scale factor doesn't have to be a whole number. It could be a decimal, it could be a 0.5, it could be 2.5, it could be a 10 or a 20 or 100 million. It could be whatever you like. It can be an enlargement or a reduction in size. It just can't be negative here because it doesn't make sense to have negative centimeters. And it can't be 1 either. So that's the only other exception. It can't be a scale factor of 1. Otherwise, you're not changing the lengths of the 3 sides. Okay, and so in this case, I can say your triangle ABC is similar to triangle GHI. Again, notice the corresponding angles AG and their positions in my similarity statement. BH, BH, CI, CI. They have to be written in order. Okay, so here's another question. Is something similar to another triangle? This is kind of like your proof question. Prove that 2 triangles are similar. Okay, so how do I prove? Well, one of 3 methods. Check 2 angles, check 3 sides, check 2 sides and angle between them. Check 2 sides and an angle between them. So if I look at my triangle, I have a side, and an angle between them. Okay, so this will work. Right? If I had angle D here, then it wouldn't work. If I had angle D but not 60, then I couldn't prove it. But I have the angle between them, so I can. So the way I do this is by looking at a similarity statement. So is triangle ABC similar to triangle DFE? Okay, so what are my corresponding sides? Well, I have the way you write this statement, the ratios for my side lengths, is by writing down the ratios of the corresponding sides, starting by the two letters that make up the length of that side. So if I have AB on the first triangle, the corresponding side would be DF. So I'm going to divide DF to find that scale factor. So again, DAB and DF are corresponding sides. So that's one way. That's one ratio. Now for a triangle with three sides, you're going to have three ratios. So the other two ratios are AC over DE. So AC divided by DE. And the last one is BC over FA. Sorry, FE. Don't want to confuse you with these other extra letters. So FE. And that's going to give you, now if this was a similar triangle, then I would have all three ratios the same. Now I don't have DF, so I'm going to erase DF. So remember, it's side, angle, side. So I only have to check ratios of two sides. So this is going to be my two corresponding side pairs, ACDE and BCFE. Okay, so AC over DE, if I look at the numbers, AC is 2.4 and DE is 1.2. So far, so good. And if I look at BC over FE, BC is 3.7 and FE is 1.5. Okay, so 2.4 divided by 1.2 is 2. 3.7 divided by 1.5 is a number that's not 2. It's going to be, I believe it's 2.4 or 2.6. 3.7 divided by 1.5, 2.46 or 2.5 or so. Let's round that. Okay, so now if my ratios are different, then this triangle is not similar. So therefore, not similar. Okay, to be similar, that these two numbers would have to be the same, 2 and 2, and you have your corresponding angle between them, 60 and 60, so that's okay. But the ratios of the sides, the scale factors are not the same. Okay, let's look at example 2. Calculate the scale factor that relates the side lengths of the similar triangles shown. So in this example, here you're proving, this is a proving question, prove that two triangles are similar. Here, you're not proving anymore, you're told that the triangles are similar. So based on the knowledge that they are similar, you have to show me what the side lengths are. Okay? So set up your similarity statement. So triangle, let's do this KLM, similar to triangle. Okay, so what are my corresponding sides? K corresponds with N. They have the same symbol for your angle. So the first letter has to be N. Angle L is my 90-degree angle, so angle P is my 90-degree angle on the other one, so NP. And then my last one, M and O. So O would be NPO, so triangle NPO. That's how you have to properly write it. So you just can't say NOP or PON. It has to be NPO to match with the KLM that I wrote in this order in the first triangle. So this triangle says triangle KLM, the triangle formed by connecting KLM is similar to the triangle formed by connecting NP and O. So let's write down the so when you're doing a question like this, angles don't matter as long as you can see that they're similar. But the angles don't matter in calculating scale factor. What matters is the ratios of the side lengths. So I'm going to look at my three sides of my first triangle. So it's the bigger triangle. So I like to put the bigger triangle letters on top like I did in this question. The bigger triangle was on top. So when I create my fractions, I put KL. And I also have KM and LM. Okay. And so corresponding with KL is going to be NP, so KL over NP. Corresponding with KM will be NO, and corresponding with LM is PO. Okay, so KL over NP. KL is 11 centimeters. NP is equal to B. It's a variable, so we don't know. KM over NO. So KM is 12. NO is 6 centimeters. So that I can calculate. LM over PO. So LM is C and PO is, well, we don't know what PO is. So that's a question mark. But 12 over 6, that's equal to 2. So we know our scale factor is 2. And we know that's true for all three pairs of sides because this is a similar triangle. We are told it is a similar triangle, so they have to have the same scale factor. So if 11 over b has to equal to 2, then b has no choice but to be 5.5. So 5.5 is equal to b. Now, c over po. What do we do there? Well, can't do much. We know c over po is equal to 2. And the only way to find c is if I use the Pythagorean theorem, right? So if I can't find c by relating the scales factor sides, because I have two unknowns here, c and po I don't know. So how can I find c? So I can just look at this triangle here and recognize that I have a right angle triangle, and I have a hypotenuse, which is 12, and I have a one side length, which is 11, and c is the other one I'm looking for. So by Pythagorean theorem, 11 squared plus the unknown side, c squared, equals hypotenuse squared, 12 squared. So c squared equals 12 squared minus 11 squared, if I move the 11 over the other side. And so c squared is equal to 144 minus 121, which is equal to 23. And if I just want c, I'll take the square root. The square root of 23 is my answer. Okay, and leave it as a square root, because if you convert this to a decimal that's repeating, then you're going to have to be forced to round it, and then, well, your scale factor wouldn't be as accurate anymore. Okay, so example 3. Here are two triangles. So show which two triangles in the diagram are similar and then determine the side lengths x and y. Do you see two triangles in this picture? Well, if you don't, well, the first one might be obvious, this small one right here. But the other one is formed by D, B, and A, the big one. So you can have a small triangle inside a larger one. That's fine too. So in solving problems like this, again, we're not asked to prove, we're just asked to find the side lengths. We're already told that these two triangles are similar. So it's a good idea to maybe just break them down into component triangles. So here we have DCE, this side's 6, this side's 3.6, and down here is 6. And I have the big triangle A, D, B, and A. And so D plus this 6 plus this 8 give me a total of 14. And on the right side, I have 3.6 plus y, so 3.6 plus this y here. And on the bottom, I have x. Okay. Now, you're allowed to have a letter represent the same common corner on both triangles. That's okay. So when I write my similarity statement, I'm going to write it like this. So triangle DCE is similar to triangle DBA. So make sure you line up the corresponding sides correctly in the correct order. Okay, now this similarity statement will help me write out my ratios for my corresponding sides. So let's write out the ratios for the left side, DC and DB. So I write the bigger triangle on top. So DB over DC equals 14 over 6. Okay, if I do the bottom corresponding side, so CE and BA, so the bigger triangle on top, BA over CE equals x over 6. And the third corresponding side, the right side, DE and DA, so I will do the big triangle on top, DA over DE equals 3.6 plus y over 3.6. Now, if these two triangles are similar, then these three scale factors should be the same, okay? So what I can do then is equate the scale factors to each other. So I can say 14 over 6 equals x over 6. So 14 over 6 equals x over 6. Now I have an equation that I can solve for x. X would have to be 14. Okay? Similarly, I can do the same thing. I can pair up this one here with the one I know, 14 over 6. So I can say if the scale factor is 14 over 6, that's equal to the other pair of corresponding sides, 3.6 plus y over 3.6. And now I can solve for y. Now how do I solve for y? I have an equation with two fractions, and I have a decimal in those fractions. Well, it's not that difficult. I can take both sides multiply them by 6, and I can multiply them by 3.6. So by doing that, it allows me to cancel the 6 on the left with the 6 on the bottom. It lets me to cancel the 3.6 on the bottom with the 3.6 I'm multiplying on the right, and it simplifies the equation a lot for me. So on the left side, I'm left with 14 times 3.6, which is 50.4. So 3.6 times 14 is 50.4. And on the right side, I have 6 times bracket 3.6 plus y. Now, if I distribute the 6 inside my brackets, I'll have 6 times 3.6, which is 21.6. So on the right side, I'll write here 50.4 equals 21.6 plus 6y. Now, if I subtract both sides by 21.6, I will get 28.8. So 28.8 equals 6y, and if I divide both sides by 6, I'll get my answer for y, which is y equals 4.8 centimeters. And that's my y, and my x is 14 centimeters, and that's it. That's my answer. Solving for x and y. Now, nothing here in the calculation for scale factor involves using angles. So only look at the side lengths. Write out the pairs of corresponding sides. Okay, and that ends this video.